Now let's see to the next figure. Okay, let's take it as I will draw it lightly because I have to draw resistances here. Right, now make it dark. Right, A, B, right, and all of them are R. See guys, the questions which can be asked in the examination, they might not be, all of them might not be R, there will be different values. I'm just making guys understand how to do a problem like this. Clear? Which type of sections, or how would you solve this one? Again, you can do floor folding symmetry here. Why? Up and down same, right? You can do folding symmetry as well as you can do a mirror symmetry. Both of these guys are feasible, but I will go by what? Mirror symmetry, because it requires least amount of time when compared to folding symmetry. Clear? Because you have to look into a lot of cases, but mirror symmetry is much more easier as per me. Both of them are feasible, but folding symmetry has a little bit criteria to be followed, whereas your mirror symmetry doesn't have. Just you have to have whether one side can be an image of the other side. That's it. See, so I'll go by for mirror symmetry here. So where I'm going to consider this mirror symmetry or mirror, I'm going to consider this point. Right, this is the mirror side of this LHS and RHS. Now again, what criteria or what we have to do, make this one plus and this minus. Now we have current division I1, this is I2 and this is I3. If I1 is moving outwards, this section will be having I1 into, because this is a mirror image here. This will be I2, this inside will be I3. See, all the current I1 has reached here. All the I2 has straight away passed here, and similarly I3 straight away passed in this direction. So there is no flow of current between these upper and lower R. So that means I can neglect them, because no current flow means there is no branch like that. So equivalent circuit will be like this, right? R, R, right? Then in between there are two R, R, then there is another R, and this R. Now this is easy, right? So this is 2R, 2R, 2R. 2R is parallel to 2R is parallel to 2R. So what is it? 2R by 3. You got a straight away answer, right? So once you look into the circuit, you can never realize whether it is parallel or series. But looking at it, you can understand there is some symmetry in this circuit. That time you can see whether I can go by I can go by your mirror image form, or I can go by folding, right? Most of the time I would prefer mirror symmetry, but some cases folding symmetry are supposed to be done. There is no other way. At that condition, you have to understand how folding symmetry is done, right? This much is clear. Now let's see whether I can solve this circuit by folding symmetry, right? We can solve it. I told you now we can solve it, but it will take a little bit of time. So I'm going to take another page, guys. Right, how we are going to solve, let's see. I'm going to keep the paper below so that we can understand the circuit. See, I'm going to make here itself. See, folding symmetry, potential, voltage. So this point, if I am taking A, I'm going to take this itself. Let's say I told you when you are considering folding, you have to take the folding section along the point where you are asked to find the equivalent resistance. You are asked along AB, so you have to take the folding from there itself. So I'm going to fold it like this, right? So when I fold like this, if this point is A and this point is B, let me name this point as X, then this point also will be X. I'm going to fold it, and let's name this point as O. This much clear? Now I'm going to redraw. A and X is having how many resistances? A and X is having R. A and X is having another R, means these two resistances are in parallel, A and X, right? Between A and X there are two resistance. So when I redraw, so A and X is having two R's, this R and this R, and they are in parallel. So equivalent A, and between X I will draw R by 2, right? Next, between X and B, how many resistances are there? Again, two resistances are. So equivalent resistance R, parallel means between X and B there will be R by 2. Right? Clear? Now between X and O, let's make this point as O. X and O, see? Again, there are two resistance R and R. So equivalent resistance, parallel resistance means between X and O it is R by 2. Clear? Right. Between A and O there is only one resistance, that is R. Between O and B there is only one resistance, that is R. Circuit is completed, and it is a resistance bridge, guys. R by 2 R, R by 2 R. So ratio is same. So this between X and O resistance R by 2 goes off. So there is A and there is B. So there is a single resistance R by 2 up. This is another R by 2. This is an R and this is an R. Now find the equivalent resistance. R by 2 series, they become R up, and R and R 2R. So R is parallel to 2R. So equivalent resistance is R1 into R2 divided by R1 plus R2, that is 3R. So the answer is 2R by 3. You got the same answer previously also. So this circuit we could solve by both what? Mirror form as well as folding symmetry. Clear? Right. See guys, when I am solving, it will be, or it might be fast. So take your time, understand, or try to solve it by yourself. Right. And if I am fast, you guys can pause the video and repeatedly hear it. Clear? Let's move on to the next circuit, guys. Right. So I will draw another circuit. Okay guys, we are having another circuit. Again, it looks good, right? You are asked to find the equivalent resistance across A and B. First we will do by folding method, as well as I will show you how to do by your mirror symmetry also. So folding means from where I have to fold, obviously I have to fold across these two guys, right? Like this, same type, right? Now what is the procedure? Hope you remember. You have to make, suppose this also will be point A, this point also will be B. This much clear? Now we have to put names for or potentials. Suppose this is X, I'm going to make this Y, and this is Z. So if this is folded here, then X will be this, Y will be here, and Z will be here. This is same as the rhyme repetition. Let's make this point as O. Clear? Now between A and X, see, this much process I have taught. Within few seconds, how can you solve? That much calculation should be done in your mind. Between AX, right? Suppose I start from here, A, right? Now X here, right? Now between A and X, how many resistances are there? A and X 1, A and X another R. So A and X is having two resistances and they are parallel to each other, right? Hope it is clear. So R and R parallel means the equivalent resistance becomes R by 2. Clear? Now A and X is completed. Now let's move on to X and Y. X and Y is having one resistance here. X and Y is having another resistance here. So X and Y is causing how many resistance? 2 R's in parallel. So it becomes R by 2. So stop till Y. Now Y and Z. Y and Z, one resistance here. Y and Z is another resistance. They are parallel to each other. So Y and resistance are having R by 2. Clear? Now Z to B another R, B to Z another R. Both are in parallel. So it becomes again an R by 2. Clear? Let's make this B. Right? This must finish? No. Entire is completed. We have not considered this. X and O is having R. Right? X and O is having R. Is there another X and O? Yes. X and O is having another R. So X and O, that means again if I am marking this point as O, it is having 2 R's in parallel, so this resistance becomes R by 2. Now again Z and O, so between Z and O there is an equal resistance of R by 2. So complete, the circuit is complete, right? Now you just have to calculate. So it will be what? This is R by 2. This R by 2 and R by 2 in series, so it becomes R this R by 2 are in series, so again it becomes R, right? Then there is an R by 2 here. This is A and this is B. Right, now do the calculation. R and R are parallel, so the equivalent circuit again will be, this is R by 2, sorry, R by 2, this is R by 2, and this is R by 2. So it is 3R by 2 is the equivalent resistance. You got the answer? Right. Now we will do it by what method? We will do it by flipping method or folding method. Right. Now we'll do by what method I was telling. I just wrote the entire thing. See, this terminal will be giving positive and this terminal will be given negative. So current division becomes I1, I2, right? Here there is another branching, so I will name it as I3 and I4. Now suppose if I consider this as a mirror, right? Can this consider this also? It's okay, no problem. But I am not considering this because I have taken this terminal for folding symmetry, right? So we'll take a separate one. So this is your what? Mirror symmetry. So this is a symmetry of this one, image of this one. So this is I1, I2, I3 and I4. So here also I3, I4 in opposite direction flowing, I1 and I2, right? Same scenario. So as you can see, I1 is flowing here, then I4 is flowing here, then it is flowing here, I3 is coming here, I3 is coming here, right? This is flowing and the same I3 is flowing here also. You are not able to see 3 here, this is 3, right? This I3 current is flowing here, I4 has reached here, similarly I2 has reached here, right? This, right? If you want, you can branch here also if you want. Suppose let's make this one as I5 and this is I6, means this also will be, right, this moving out, this is inside, so I5 and I6, right? So same current here, I5 is reached like this, I6 has reached like this. That means this point O is irrelevant. There is no branching which is done, right? I3 go on like this, I6 go on like this. So I can convert this circuit into an equivalent circuit of this form. See? Like this R and R, right? So this is R, right? Then there is one R, then A, sorry guys, right? Similarly, then is R. This terminal breaks off. There is no sense of it. R, R. This becomes the equivalent circuit. This has to be drawn like this, okay? Right, now it is easy. R and R, R and R. Right, 2R parallel. So this becomes R. I hope you understood. This becomes 2R. This becomes 2R. This 2R and 2R parallel. So 2R by 2 becomes R. Then this R, this R, this R is in series. So 3R. The same here, right? So here also 3R. So 3R parallel in two branches means equivalent resistance is 3R by 2. Same answer. Clear? I might be fast, guys. You guys can do it by yourself actually. I have taught how it must be done. Clear? Now what happens? The question is not like this. The AB terminal, your question, same circuit, but the AB terminal has been changed from here to here. What would you do? Can you do your folding? No. Across AB means I have to fold like this, right? Can I fold? No. So obviously you have to go by which method? This method, right? So this terminal goes off A and B. Same method goes, right? Same entire process is same, but the terminal here becomes A and this becomes B, right? So how do you solve? This becomes what? R, 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 R. So it becomes, remember it was R. So this is R, right? So what will be the equivalent circuit would be? This is R, R. This was what? 2R, 2R parallel. So it was R. Then there is another R, 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 right? And this terminal was equivalent to, remember, R, right? To R, 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 R. 2R, 2R parallel, R. Then the equivalent was asked here. So here 1, 2, 3, 4, 5. These 5 resistors are in series. So 5R is in parallel with this R. So how would you calculate? R1, R2 divided by R1 plus R2. The answer will be 5R by 6. See? You just change the terminal from where you want to calculate the equivalent resistance. The answer has been completely changed. This much is clear? Right. Take your time, guys. It is very easy to solve once you understand the scenario. Clear?